Good morning to the audience and participants of the ICon-MaSTEd 2024. I'm Angelo Pacala from the Philippines, but currently I'm working as a expatriate teacher in the Presidential School of Uzbekistan in Karachi City, Uzbekistan. So may I introduce to you my research title. This is the Tracking the Terminal Velocity and Energy of a Parachutist, a video analysis for physics classroom experiment. So this experiment was conducted in my school inside the classroom together with my students. So a common issue in the classroom is the experiment on terminal velocity, because this is a very difficult experiment, and falling bodies, we can measure the time of the fall, but it will be difficult to measure its velocity. Where will the like for example, where will the resultant force will be equal to zero, wherein the weight and then the air resistance will be equal. So considering that there will be a lot of the different uncertainties in the measurements of the velocity, or even with the time with the use of the stopwatch. So there will be like the human error, random error, with the use of the stopwatch, the ruler. So the presence of air resistance can also cause fluctuations in the velocity of the object being dropped, affecting the accuracy of the results, according to source number 15. So most teachers will just escape the experiment on terminal velocity and only doing some theoretical explanation about this topic, and of course mathematical calculations. So in this experiment that I did, I used the tracker, video analysis, and tracker video analysis and modeling to help reduce these measurement uncertainties. So the tracker video analysis is a software that allow users to track and analyze the motion of objects with the video, according to source number 8. So the software uses algorithms to track the position and the movement of the object over time. So the objective of this research is to determine the terminal velocity of different masses of the parachutists, determine the relationship between terminal velocity and masses of the parachutist, and check if this is according to literature correct, verify the generated kinetic energy versus time graph and potential energy versus time graph from the literature, and determine the classroom implications of using tracker video analysis on free fall experiments as cited in the literature. So basically, this experiment is about the masses. The independent variable is the masses, and then the terminal velocity will be the dependent variable. And taking a look at this, capturing this in a video and uploading in the tracker video analysis and modeling. By that, I can generate a graph, taking a look at the terminal velocity, the kinetic energy, and then the gravitational potential energy, and verifying this according to the literature. So for the theory, we know that the resultant force of a falling body will be equal to the weight minus its drag force. So the drag force, according to literature, is equal to 1/2 times the drag constant CD, the times the velocity squared times the cross-sectional area. At some point, the air resistance becomes equal to the gravitational force. So, and the object no longer accelerates, and then the velocity will be constant. So at this point, since the drag force and the weight is equal, so we can equate that the weight is equal to that 1/2 CD rho V squared times A. So according to source number 23, if we will solve for the velocity, it will be square root of 2 mg. So that mg came from that W over CD rho times the area. So now I am concerned here with the masses as the independent variable. So if we will plot mass, square root of mass versus the velocity, the gradient will be square root of 2g over CD rho times A. So from that, actually, we can calculate the acceleration due to gravity, which is the g from that particular instance. However, in this result, it was not my objective when I tried doing calculating the G, I found out that I was deviating from the true value of J. It's because even if this experiment reduces the error, still the value of G, I cannot calculate. That means I need to try and try again this experiment. So that will be one of the limitation of this particular research. So the materials, so as you can see on the picture, the material includes a retort stand with clamp and a boss, meter ruler, masses, do-it-yourself parachute made from cloth and thread. And the masses, I have 6 pieces of masses. So this is the tracker. This is the interface of the tracker. Obviously, I have already uploaded the video here. So what if you wanted to emulate this experiment, what you need to do is to capture first the video of the parachutist falling with a ruler here. As you can see, there's a meter ruler. This will be the source of measurement for the tracker. So you need to take a video first from your mobile phone, upload it here, and then you can now capture this kind of masses versus the y-axis, masses versus the y-axis. And as you can see here, there are different measurements like the time, the x-axis, um, length, and the y-axis length, because you know this is moving in a two-dimensional, so there will be length, and then there will be, there will be y-axis and then the x-axis. So you can also have here, if you click here, this green up arrow and down arrow, you can have you can have the energy and some other physical quantities. So these are now the results. Sorry, this is the results. So as you can see, this is now the terminal velocity, displacement versus time. So the terminal velocity based from the tracker is this parameter A, which is about minus 1.36 plus or minus 0.01 meter per second. So where did I get this value? I get this value by creating a tangent line from here. So what I found from the graph is that it is having a straight line at this point, more straight line at this point. So I consider this as the terminal velocity of the object. So I collected this different terminal velocity by adjusting the masses, by having different masses, and this is now the data in table 1. So the masses are there from 32 from 0.032 kilograms to 0.132 kilograms. So in your experiment, if you will emulate this, you can extend the number of masses. So the terminal velocity of this is recorded. So this is considerably correct, because based from our equation here, if this CD, rho, and area are constants, and the G obviously is constant, there is a direct relationship between V and M, square root of M. So in this table, we can see that we have verified that equation, that if the mass is increased, the terminal velocity also increased. So therefore, if we will graph that, I graph this in Microsoft Excel. So we have this kind of graph. A line of best fit was generated, a straight line of best fit. So this graph now verifies our equation, that indeed there is a direct relationship between the terminal velocity and then the mass, as far as equation number 4 here is concerned. So the energy of the parachutist are also shown in the picture. So we can just click on the tracker energy. You can choose kinetic energy or GPE. Now, if you will look at some books and researches on the internet, you will see that the GPE of a falling object is decreasing while the kinetic energy is increasing. So this graphs that was generated from the tracker verifies the theory from the books and from related literatures. So in conclusion, this experiment proved that the tracker video analysis can determine a parachutist terminal velocity and energy. The data on terminal energy versus the square root of the parachutist masses were consistent with the theoretical perspective. So the straight line of best fit in figure 6 proved this hypothesis. The gravitational potential energy, kinetic energy, and total mechanical energy were consistent with the literature. However, the TME graph was not consistently constant because the work done by the air resistance was not considered. I did not show this in the picture. So the TME was not entirely constant. That means if you wanted to do this experiment again, so you need to add more data, and from that data take the average, and you can have a more constant total mechanical energy. So what is the gist of this experiment? The implication is that we can also do some experiments on the uh, terminal velocity, not just doing some theoretical explanation and calculation inside the classroom, but we can also prove this theory by doing this simple experiment. Yet it is very intellectual for the students to learn these things. They will have some aha and wow moments when they have found out that what they are doing theoretically is also applied in a real life situation. For example, for this one, having some kids toy like a parachute, a do-it-yourself parachute, can also verify some physics experiments. So that's all from my end. Thank you for listening, and thank you for your attention. And again, congratulations to the ICon-MaSTEd 2024 participants, as well as the hosts and management of this event. Thank you so much and have a great day ahead.